Introduction to Control Systems.
Hello all, welcome to our YouTube channel. Today we will be discussing a new electrical series, that is control system. Let us understand the basics of control system with simple examples. If there is a guidance system and it has to hit the enemy target precisely, then control system is very important. In your car, the response to drive will be given by act pedal, and if the same response of act pedal to wheel has to be gone, then control system is very important. In all the real world, whatever the components or systems you are seeing, everything needs control system. That is why control system is the basic thing which is required in all the systems. So let us understand what is this control system. Control system is nothing but the word only says controlling the system. Means if there is a system and there is an objective of the system to perform some task, some objective, and there is an input, achieving this objective using the inputs is done using a control system. The way of controlling these inputs to achieve the object is called control system. To understand the control system, first we have to understand what is the system definition is there. Means to control the inputs, you should understand what is the system behavior. System behavior is understood by a simple terminology called transfer function. In electrical engineering and electronics engineering, this word you will be hearing n number of times, this transfer function. So what is this transfer function? Transfer function is a mathematical term used to define the response of the system. That means it's just output function divided by input function. Any system, any mechanical system, electrical system, which is expressed in terms of output function to the input function, then it is called transfer function. Why it is very important? So for example, this is a transfer function t. So next time if you want to understand the system behavior, you just have to use this t with the different inputs. That means t into input will give you the output. So that is the importance of t. For a particular system, this transfer function will be constant. It will not be varying. So that is the reason this transfer function is very important for any system. This can be used for mechanical system, any electrical system. Let us take some examples how this transfer function is used. Let us take one mechanical system, a spring loaded with mass m and attached to a fixed constant. So this mechanical system, when you apply a force and then the response is to reach certain distance x, that is the output. Output is making the system to reach certain distance x. Then what are the inputs to the system? Input is force applied. So for this to understand what is the transfer function, we have to just make the function arrangement such that input is f force and output is distance. But you cannot just divide input by output, because first we have to understand what is the response of input and what is the response of output. So before taking this directly input force and output as distance, first we have to write it in terms of mathematical term, and that too the response of the system should be understood. That is called input function. and definition of output x in terms of output function, and just later we have to divide f of x divided by x of x, will get transfer function t. And then next time if this transfer function is known for any output required, now we have calculated for distance x, now if you want to calculate it for x2, then just use this transfer function such a way that you will get to understand what is the behavior for x2, x3, x4. That is the advantage of transfer function. In electrical circuits, if there is an electrical circuit made up of resistor, inductor, and a capacitor, okay, this is a circuit, and here we are measuring output and input is varied here. So now to understand this behavior, we have to make the output function divided by input function, then we'll get the transfer function of the system. What, how then this transfer function is useful for next time if you want to change the output value to different value, then use this transfer function, and then you will get to know what type of R and L value and capacitor value you have to change, or you have to change input voltage. That will be understood by just calculating this. This is the advantage of transfer function. There is one challenge here. You transfer function expressing directly in terms of time domain means if this transfer function is there, then output function if you are defining by v of t, vo of t, and input function divided by vi of t in time domain if you are expressing it. The challenge is if it is a differential equation, because for the same equation if you want to write, then we'll have output equation will be, if you just write in output equation in terms of time, it will be what is the output voltage of capacitance integral of ic dt, 1 by c integral of ic dt. And what is the input equation? Input is sum of all the three, this plus this plus this, so it is ir plus ldi by dt plus 1 by c integral of ic dt. This is the equation. Now to solve this equation, it is a complex differential equation. To solve this, it is very difficult. That is the reason there is one more advantageous computation is available, that is Laplace transform. Why Laplace transform is very important and very useful in this application is this Laplace transform will convert all this complex differential equation into algebraic equations. Laplace transform converts equations into algebraic equation. So if you convert this differential equations in terms of algebraic equation, then it will be very simple. See, reading this is very difficult, but if you convert this same into, for example, 1 by cs plus r plus ls plus 1 by cs. See, this is very simple to understand and simple to solve this kind of equation. So this is the reason transfer function always converted into S domain. So this is one important concept. Now you understood what is transfer function and things. Next, one more important concept is there, that is feedback. What is this feedback? Feedback in control system. Feedback is nothing but, for example, this is the transfer function. this is input and this is output. So if you want to control this output by input using transfer function, it is one simple method, and that is called uh, just by varying the transfer function variables you can control the output, or by varying the input you can control the output. This is very simple. That is why it is called open loop control system. It is very simple. There is nothing complex is there. Just by varying the transfer function you will be able to control the output, or by varying the input you will be able to control the output. Very straightforward. That is called open loop control system. And there is one more thing called feedback based control system. That is a transfer function, and a part of its output is fed back fed back to the input. It's called closed loop transfer function. Closed loop transfer function. Why it is again very important thing is, see now, for example, we'll take the previous example which we were discussing. Okay, that is there is a missile, guided missile, and you are targeting the enemy very precisely. Okay, and then the transfer function is the controller, how they are controlling this missile's angular position. That is the output is theta of the angular position of the missile, and the input is from the missile tank, and the transfer function is the way of controlling this missile, guided missile. So now if it was just a simple open loop control system, then how it would have been, the like if you directly targeting the enemy and there was some error initially. Okay, and then instead of going to enemy it has gone little bit far, there is an error. And then to reduce this error, next time if you control, again it might go to some other position, and again there will be error. So every time there is change in position of the output, there will be different types of error, and it is very difficult to achieve the precision. But in case if there is a closed loop system, what is this closed loop system? You know what is the error. This error is fed back to the guided missile system. This is the error, and then based on which controller system will adopt its transfer function such a way that this error feedback is taken into consideration. Then next time the missile will definitely very closely, it will be landed towards the enemy, and even if there is little bit again there is a error, another precision will be taken, and then again it will hit the enemy. So this is the advantage of closed loop system. Closed loop system is taking the part of the output, and that part of the output, whatever is called error in the system, and feeding forward to the transfer function, that is called closed loop transfer function. Here there are again two things: feedback transfer function, transfer function. So feedback transfer function is you are taking the output and feeding to the input. That is called feedback system. And feed forward system is, already you know what is the error, and the error from the input is already calculated, and that is given to the output. Extra errors in input is considered as the behavior, and that is feeded forward in the output. That is called feed forward transfer function. Most of the control system uses feedback system. Some are using feed forward system where input error is very maximum, then they will be using this feed forward transfer function. Okay, that's about the basics of control system. In next session we'll be talking much about the response and electrical circuit terminologies in control system.